derivative by the chain rule. Let's go ahead and begin. In our previous derivative shortcut limits us. It only works for simple ones like the y equal x to the seventh or y equal cosine of x. But when you have quantities being raised to powers, you need to do something else. So for example, if we had y equals this big old fatty quantity to the seventh, or y equals cosine of something else, instead of just cosine of x, it's cosine of a quantity of stuff right there. We do this thing called the chain rule. So recall that the derivative of y is dy dx. Okay, this says the derivative of y with respect to x. Okay, again, I'll say it again. The derivative of y with respect to x. So if I took the derivative of this y, it's with respect to this x right here. So algebra lets us split up dy dx by substituting in a u substitution. Notice these du's, if I did some algebra, they would just cancel out right here, and I'd be left with dy dx. And so this du that we're going to insert, you guys, is going to be our chain that we're going to plug inside of here. So I'm going to do some u substitutions using this trick right here. Okay, so let's go ahead. It'll be easier just to explain as we get going with this. So steps to the chain rule here. First step is to choose your u, and your u is the inside stuff, the stuff inside the parentheses, or the quantity, or the stuff inside like a radical sign, or the cosine of something else other than x. Okay, so it's all your inside stuff. And then rewrite your original equation with your u substitution. So now it's going to be y equals something in respect to u. All right, and then take each derivative and then multiply them together. So we're going to take this is how it's said, the derivative of y with respect to u, and then you're going to be taking the derivative of u with respect to x. Okay, so here we go. And then substitute back in your u back in and simplify everything. Okay, so here's that first one, you guys. Okay, so I'm going to let u be the inside stuff right here. So u is going to be that stuff inside the parentheses right there. Okay, and I've had this on all the rest of the pages here. So this is just section C right there. Then we're going to rewrite the original equation and write this as y equals, now this is u to the seventh. Okay, so there it is right there. Now I'm going to take dy du, the derivative of y with respect to u, is bring this 7 down and become 7u to the sixth. And the derivative of u with respect to x is right here, is going to be 5x to the fourth minus this 3 comes down, x to the fourth, so 12x and then squared, and then plus that 1 right there. Okay, so then dy dx then becomes dy du times du dx. So it's going to be bluey times reddy. So this bluey times this reddy right here. Okay, and I'm almost done. Now I just got to substitute the u back in. So this u is going to be this quantity right here, is going to go right here. Okay, so final answer, and you just leave it as that big old messy thing right there. Whoops, I forgot something right here. I forgot my sixth right here. Golly. All right, let's do that. There's a little 6 right here. Let me put that. Sorry about that. 6. Okay, there's the answer right there. Okay, so it's 7, this quantity to the 6 plus 5x to the fourth minus 12. Okay, not plus, but there it is right there, that big old messy thing right there. You guys got it? Okay, let's do it again. I got some more examples here. Let's do the other one here. Okay, u is going to be this inside stuff right here. Okay, so and then y is going to be cosine of u now. Okay, and then I'm going to take the derivative of y with respect to u. So the derivative of cosine is negative sine. Remember that? Got to know that stuff. And the derivative of u with respect to x is this one. So this 3 comes down, becomes 15x squared. Okay, last thing I got to do now is substitute in u. U was this quantity 5x cubed. See if I wrote that stuff down right there. Yeah, there we go. Okay, so that's the answer right there. I think I got everything. I did. Okay. All right, let's try this one. Okay, u is the inside stuff. All right. So, and I'm going to visualize that as a quantity to the 1/2 power. Okay, so u is going to be that 1 minus 4x. So I have y equals u to the 1/2. All right, so dy dx is dy du times du dx. Okay, so dy du is the derivative of y with respect to u. Okay, so this 1/2 comes down, and I take 1 off of 1/2, and it becomes negative 1/2. And then du dx is the derivative of u with respect to x, so the derivative of this is negative 4. All right, so there it is right there, and then this 1/2 and this -4 becomes -2. Okay, you with me on that? And then u to the 1/2 is 1 over u to the positive 1/2, so and which is the square root. So that's the final answer right there. Okay, for that one. You guys getting it? Okay. All right, let's try another one here. Okay, so I have y equals -7 over the quantity 2x minus 3 squared. Okay, think of that as the quantity 2x minus 3 to the -2 power. It's easier to do that. And then I'm going to go ahead and let u be the inside stuff. So you have y equals -7, u to the -2. All right, and then there we go, and the chain rule. And then go ahead and substitute your u back in, and then it goes back downstairs. And so there's the final answer right there. All right, I think I have one more. Yeah, I do. Okay, so y equals tangent cubed of x, okay, which is tangent of x cubed. Okay, so u is going to be the tangent of x, so I have y equal u cubed, and then it's all just fundamentals after that. You guys can substitute that back in. And there's your final answer. Alrighty, and if you are sitting in my calculus class, I would assign that as your homework assignment.